the next generation science standards, comprise a set of more than 800 standards, which maintain more than 1,000 relationships with each other. As such, the NGSS form a rather complex dataset. Much of the available documentation of the NGSS presents this dataset as linked tables, with each table showing only a single or a few closely related standards. However, when we display the NGSS as a network, with standards represented by network nodes and relationships between standards represented by links connecting the nodes, we can make viewing the NGSS a lot more flexible and interactive. By viewing the NGSS this way, we also start to see patterns and structures which would be difficult to detect with tables. For instance, when viewing the entire NGSS as a network, we immediately see that the NGSS actually consists of 4 separate grade band specific networks. A kindergarten through grade 2 network, a grade 3 to grade 5 network, a middle school network, and a high school network. When we zoom in on one of those networks, in this case the network of 3rd to 5th grade, we see that standards come in 5 types. Topics, shown in purple, and performance expectations, shown in gray. Science and engineering practices, shown as blue nodes. Disciplinary core ideas in orange. And cross-cutting concepts are displayed as green nodes. When we zoom in on performance expectation 3-LS4-4, which states that 3rd graders can make a claim about the merit of a solution to a problem caused when the environment changes and the types of plants and animals that live there may change, we clearly see how the performance expectation is part of 3rd grade teaching of the topic biological evolution. We also see how the performance expectation connects with its 3-dimensional learning aspects. It connects, for instance, to 2 disciplinary core ideas, one that explains that changes in the environment affect organisms in different ways, and one that states populations of organisms live in different habitats and that changes to those habitats affect the organisms. The performance expectation also connects to the science and engineering practice of making a claim about the merit of a solution to a problem by citing relevant evidence. And finally, the performance expectation connects to the cross-cutting concept of seeing the world through the perspective of systems theory. Systems theory itself, since it is a cross-cutting concept, connects not only to the performance expectation we have just seen, but it also connects to 5 other performance expectations in this grade band. These other performance expectations maintain their own connections to standards and may even be associated with a different topic. For instance, performance expectation 5-ESS2-1 develop a model using an example to describe ways the geosphere, biosphere, hydrosphere, and/or atmosphere interact, resides under the 5th grade teaching of the topic Earth's Systems. Earth systems, however, as most topics in the NGSS, is a topic which is addressed across grades. We can explore that by viewing the NGSS network of standards not by grade, but by topic. This view shows how the topic Earth's systems features across most grades. We do, however, notice a few things. We see, for instance, that whereas the performance expectations for Earth systems are very grade-specific for grades K through 5, beyond 5th grade, the learning occurs anywhere over periods of 3 and 4 years in middle school and high school. We also note that apparently the NGSS does not specify any learning for this topic in grade 1. Elsewhere in the NGSS, we observe a similar phenomenon. A good example of this is the science and engineering practice of using mathematical and computational thinking. Here we see how in the NGSS, using mathematical and computational thinking is absent until grade 5. One of the things that makes graphical networks useful is that one can display a lot of information in a relatively small space, and that networks can be extended wherever new connections are found. Let us, for instance, return to topics, this time the topic of engineering design. From the graph, we see that engineering design is addressed in each of the NGSS's grade bands: K to 2, 3rd to 5th grade, middle school, and high school. At this point, however, we might be interested in finding resources which can help teach to the associated performance expectations. To support this, we have collected the NGSS standard curriculum alignments from over 50 online K-12 curriculum collections. As you can see, for each provider, we list the number of curricular items that it has aligned with any of the engineering design standards. For instance, we see that South Metro Salem STEM Partnership offers 29 such items, Science Buddies 20, Consort Consortium 13, and Teach Engineering about 600. Because each of these curricular items is associated with one or more standards, we can display them in the network as nodes. Once here, we can select standards to which resources are aligned, and those aligned resources are listed in the table on the right. For convenience, these curricular resources are equipped with a hyperlink so that they can be directly accessed from a browser. As mentioned at the beginning, exploring the NGSS in network form allows us to visually detect patterns. Some of these patterns, however, give rise to concern because they show that not all providers interpret the concept of standard alignment identically. In this example, for instance, we see that Teach Engineering predominantly aligns its resources with performance expectations, and by implication with the various dimensional standards covered by that performance expectation. However, here we also see some alignments of Teach Engineering resources with the performance expectations cross-cutting concept. These alignments indicate that although the associated resources align with the cross-cutting concept, they do not align with the performance expectation as a whole. Other providers, however, seem to follow a different alignment convention. Here, for instance, we see an example where multiple lesson resources have been aligned with both the performance expectation and one or more of its disciplinary core ideas. What to make of this double alignment? Maybe we should ask the provider.